This is lesson 821, and I'm going to walk you through parts of problem 855. This problem is about the water balloon contest, so make sure you go through and read the information in this problem before you watch this tutorial video. All right, so we are going to make a graph and a table for each of these contestants, and we are given different pieces of information about each contestant. So we're going to start with Maggie. And what we know is that she is going to catapult, she places her catapult at the 3-yard line. So that is where she's going to shoot her water balloon from. And then we're also given that quadratic equation for her parabola. Okay, so hers is y equals negative x squared plus 17x minus 42. Okay, so what I'm going to do is I'm going to go ahead and click on the 855 student e-tool. You could also do the resource page if you wanted to work this out by hand. I'm going to click on the e-tool. And I am going to go ahead and click on contestant 1 on Maggie. And they gave us the information that at the 3-yard line, that's where she shot her balloon from. So at the 3-yard line, her balloon was at 0 yards in the air. That's where she's shooting it from. And then the other piece, they do give us her equation, so I'm going to use that to graph this parabola quickly. If I didn't have this computer, if I was doing it by hand, I could take different x values and plug them into the equation, substitute different x values in for x, and then get a bunch of points to plot. So I'm going to go ahead and put her equation in. I'm just going back to peek at that again. Her equation was negative x squared plus 17x minus 42. Negative x squared plus 17x minus 42. And then I'm going to click on this little circle and it will graph it for me. Okay, there is Maggie's parabola. Move my screen around here a little bit. All right, and so I can see that right here at 3, 0, that's where she shot her parabola from. Oh, sorry, her water balloon from, and then it traveled in the air, and it got to its highest point, the vertex, and then it traveled back down, and it finally hit the ground at 14 yards. Okay, so if I wanted to go back and throw some other numbers in my table, another important point would be where it hits the ground at 14, 0. And then I would probably want to also put in the vertex of my parabola. So at 8.5 yards, the balloon got to its highest point at 30.25 yards. I'm going to put that in my table. All right, so that's Maggie. So I'm going to go back and look at our next contestant, who is Generous. So for Jen, it says she runs down the field, places her catapult at the goal line, and releases the balloon. The tracking computer reports the path of the balloon with the graph at right. So they already gave us the graph here, so let's take a look at some important points. So we know that her graph started right here at 0, 0, and it got up to its highest point, the vertex, and then it ended down here at 8, 0. So I'm going to go ahead and put the starting point, 0, 0, and then 8, 0 into my table for Jen. So she started at 0, 0, and then it landed at 8, 0. I'm going to go back and look at what her highest point the water balloon got to. This point here is at 432. Go back and put that point in my table. And then I'm going to go ahead and see what that looks like. Okay. Now I don't know the equation of her parabola, but I do know that it's we have a picture of it on the last screen, but it starts here, gets up to its highest point, and then it falls back down. So if you would notice this parabola and gens that they gave us in the book here, they're both upside down. And what's making them upside down is this negative in front of the x squared term. So whenever we have that negative in front of that term, that means our parabola is going to open down. All right, going back to our next contestant, the third contestant, Impeccable. He accidentally launches the balloon before we're ready, and we get some information in this table below here, okay? So we can go ahead and just copy that table down into our decimals tool. Open him up. The first point was 2, 0, and then 3, 9. Over here and double check I got that right. 2, 0, 3, 9, 4, 16, 21. All right, and 6, 24, 7, 25. 8, 24, 9, 21. All right, go ahead and get those points graphed. Okay, so there is Impeccable's graph, and it's a parabola, right? So it's going to be symmetric. So it'll be the line of symmetry will be right there through that vertex, the highest point on the graph. Okay. So, all right, let's look at our last contestant, which is altruistic. Okay, it says, with your computer broken, you decided to record the balloon's height and distance by hand. Al releases the balloon from the 10-yard line, so that's where he's going to start. The balloon's going to reach a height of 27 yards, and it's going to land at the 16-yard line. So we have the point where the balloon's starting and where it's ending, and then we have its highest point, so we have the vertex. So I'm going to go put those points into my table for Al. So the first one was 0. So he starts out at the 10-yard line. It's at 0 yards in the air. The highest point it got to was 27 yards in the air. Nope, and we need to know where that's at, so we're going to come back to that one. But we know it ends at 16 yards. Okay. All right. I'm going to just plot those 2 points for now. So I can see these orange dots here. We know it started, his balloon started there and it ended there. And we know the highest point ended at 27 yards. So I'm going to put that on my table. Now, the highest point's got to be right in between this 10 and this 16. So I want to find the halfway point between 10 and 16 because I know this has to be symmetric. And so that halfway point is 13. So you can see that is where his parabola will reach. That's the height of his, the water balloon. That's as tall as it will go. Okay, so now using this information, looking at these parabolas, you need to decide for part A in this question, which contestants should win the longest distance and which water balloon went the highest. So you're going to go ahead and answer that and then work your way through the rest of this problem.